Hello, and welcome to Backer Breaks It Down. In this episode, we are going to further explore the basic concepts of similarity. So, as you all know, dilations can produce similar figures. Okay, and what that means is that the image and the pre-image, they have the same shape but are different sizes. Okay, those different sizes are due to the fact that the corresponding sides are proportional. That same shape is all because the corresponding angles are congruent. Now, we can write a similarity statement, and the order of that similarity statement is important because that order will identify the corresponding angles and the corresponding sides. So here we have the similarity statement. Figure ABCD is similar to figure EFGH. And notice what that means. It means that angle A is congruent to angle E, that angle B is congruent to angle F, and so on. Furthermore, I can use it to create all these ratios relating the corresponding sides of my two similar figures, and I can use those ratios to find that similarity ratio, otherwise known as the scale factor. So here in example 1, I want to know, is ABCD similar to EFGH? So first off, realize that we are dealing with parallelograms. And I know that both of these figures are parallelograms because I have an angle that is supplementary to both of its consecutive angles. Okay, that happens over here in figure ABCD. Angle A is supplementary to angle D and also to angle B. So these are both parallelograms. And of course, as you know, the opposite angles in a parallelogram are congruent to one another. Therefore, I know that angle H is also 60 degrees, and the angle C over here is also 120. So as far as those corresponding angles being congruent, is angle A congruent to angle E? Yes, it is. Is angle B congruent to angle F? Is angle C congruent to angle G? And is angle D congruent to angle H? Okay, so I know all four corresponding angles are congruent to each other. So are the corresponding sides proportional? Well, in a parallelogram, I know that the opposite sides are congruent. So in ABCD, that means side BC would also be 3 units long. Side AB would also be 5. And in figure EFGH, I know that HG would be 15, and I know that GF would be 9. Okay, so I just need to know, are the corresponding sides proportional? Well, we really just need to compare two pairs of sides here. So I need to compare, I can look at side AB, and side AB corresponds to side EF according to my similarity statement. AB is 5 units long, and EF is 15 units long, therefore their similarity ratio is 1/3. We do always simplify our ratios. So now I'm going to look at side AD, and according to the similarity statement, side AD corresponds to side EH. AD is 3 units long, and EH is 9 units long, and this reduces down to 1/3. Okay. So I have confirmed that all four pairs of corresponding angles are congruent. I have also confirmed that all four pairs of corresponding sides are proportional. So yes, these two figures are indeed similar to one another. In problem 2, we are given that these two quadrilaterals are indeed similar to one another. The similarity statement tells us that much. Quad is the pre-image. So what is the scale factor? Well, you'll notice that in figure quad, I know 3 of the 4 sides. Okay. However, in SIML, I only know that IS is 8. So I think I should really use IS in determining what my scale factor is. According to my similarity statement, IS is the first two letters, okay? Therefore, it corresponds to QU. So I can create my similarity ratio, well, scale factor. Remember, scale factor is where we go image over pre-image. Therefore, if QUAD is the pre-image, that's actually going to go on the bottom. So 8's on top. 8 is representing IS, and QU is going to go on the bottom, and that's 20. So now I know for a fact that my scale factor, image over pre-image, is equal to 2 over 5 once you reduce that ratio. To find the measures of those three angles, remember all corresponding angles are congruent, okay? I know that angle I is 85 degrees, and according to my similarity statement, it's going to be congruent to angle U. I know that angle Q is 75 degrees, therefore it's congruent to angle S. I know that angle L is 120. That was kind of hiding, wasn't it? Therefore, D has the same measure. So there exists one angle that I don't know the measure of, but remember, when it comes to the sum, I'll call it the quad sum of all four angles in any quadrilateral, they add up to be 360 degrees. So we can just do some math here to figure out the measure of angle A, which is also the measure of angle M. And when I do that math, I get that each of them would be 80 degrees. Okay, because I'm adding 120, 75, and 85 and subtracting that from 360. So essentially, we have found all these angle measures they're asking for in part B by labeling our diagram. So we know that the measure of angle D is 120. The measure of angle U is 85. And the measure of angle A is 80. Part C says to use the scale factor to find the unknown side lengths, SL and MI. Okay, so my scale factor, remember, is image over pre-image, 2 over 5. The image was SIML. If I want to find SL comes from the image. And according to my similarity statement, SL corresponds to QD. So QD is 13. So this is what my proportion will look like. I have the scale factor, which remember is the image over the pre-image, the image being SIML, so that SL goes on top, the 13 on the bottom, and then I'm going to cross multiply. So 5 times SL is equal to 2 times 13, just simply 26. And then I simply divide both sides by 5. So I get the SL, well, 26 over 5 works. We'll just leave it like that. For that second side, MI, so I start with my scale factor 2/5. MI also comes from my image, so I'm going to put that on top. And according to the similarity statement, MI is corresponding to UA, which is 25. So I'd want to cross multiply and divide. So I have 5 times MI is equal to 2 times 25, which is simply 50. And then if I divide both sides by 5, I'm going to get that MI is equal to 10. So there you have it. Similar figures. The similarity statement is important because it's going to show us the corresponding sides and the corresponding angles. Okay, and coming up with those corresponding sides, well, that's just going to help you come up with that similarity ratio. And that is how Backer breaks it down.